what we're finding is that machine learning algorithms can be used to find patterns, and then they can make decisions based on those patterns, or they can create new content. The image on the right is from a tool called crayon.ai. I gave it the prompt rare books and special collections. So you can see that AI can understand the visual characteristics of what it thinks a rare book is, but it definitely doesn't understand anything about how books are constructed. So it's a kind of fantastic artifact that illustrates the way that AI works, where it knows the most likely things to appear for a particular kind of query, in this case for rare books and special collections. So AI machine learning can process images using computer vision. It can process text and speech using natural language processing methods. So that's how things like chatbots work. And it can also process audio and video in different ways. Working with existing material, AI or machine learning might transcribe, could label or classify, it could summarize or translate material, but it can also create new images, text and video with generative AI. So the current kind of buzzword in generative AI is large language models, particularly ChatGPT, but also Bard and Bing and others. These models are trained on a lot of scraped data. If you have collections online in your institution, they might well have been used to train these models. So they read them, they sort of like ingest them and then sort of mull over them to find the patterns in them. Large language models are basically fancy predictive text. So they're great at guessing what word should come next to create something that looks like a plausible piece of text. If you want to flatter yourself, you can try generating a bio for you from something like ChatGPT, seeing how expansive and generous its language is, but also perhaps where it's gone wrong. So I found when I tried it that it did the thing that ChatGPT is known for, which is hallucinating references or making up references. So it understands the format of a reference to an article or a book chapter or a book. It will include things like DOIs, but the actual material won't be real. And that's because large language models don't know anything about the world. They don't have any semantic knowledge. They can't do maths. They can't understand words or concepts. They can't determine truth. All they can do is say the kinds of things that someone who would know about those things would say. So in a way, it's an Oxbridge high table as a service, or mansplaining as a service, it's also been called. It's possibly a bit harsh. ChatGPT have started labeling their site with some of the limitations, but it's still quite subtle. But I think the fact that we've seen a decrease in use is indicative of the fact that people have tried it and found that the inaccuracies and limitations are too much for them to kind of use it in practice. So image generation was the kind of the previous hot buzzword in generative AI. And again, this is trained on vast amounts of acquired or scraped images. So if you had images on Flickr, public images on Flickr might have been used. Facebook have obviously used their own media library of everyone's photos to train their own things. Often because the AI doesn't understand anything about what hands are or what people are, it could get things wrong. And I don't know that there's an example here of like the hands having too many fingers or various things. But if you look closely at some of these images, you can start to see that they're just not quite right. They're sort of plausible, but not very realistic. This is only one tool. There are others that are getting incredibly realistic and incredibly good. So the pace of change in this field is really vast, but also to access the latest tools, you generally need to pay. So AI is not intelligent. We're not at the point of artificial generalized intelligence. It's not conscious. It's not a magic wand. It won't solve all your problems. It probably won't cope with your messy data, and even the best catalogs in the world have got some inconsistencies and mess. That ability will change all the time. So overall, it might not be the right solution for the problems that you're trying to solve, but on the other hand, it might get you funding, and sometimes that's almost as good if it allows you to find methods to solve your problems. So taking a brief moment to look at some examples from the British Library. At some point when digitized items were ingested into a digitized manuscript system. They didn't have a way of labeling things that weren't folio or weren't fly sheets. So images like these, so cases, wrappers, various other things, were labeled fly sheets, but they're not fly sheets. So as part of other work in the Heritage Made Digital project, looking at ingesting material into new systems, they wanted to solve some of this and identify these fake fly sheets using machine learning. So they did some internal training and came up with this software that's called FlySwat. It's FlySwat, it swats fake fly sheets. There's a link there if you want to find out more about how it works. And there are various blog posts around and things. This is a quite practical project that was enabled in part because we had Daniel Van Strien, who was working with the Living with Machines project, in the team at the library and available to collaborate with others in the library on this work. So it's not easy to kind of get this work going just with the skill sets that you have available and the resources that you have available, because generally people are already quite busy with the work that they're doing. We are using Transkribus extensively across the library, mostly in quite focused ways on particular collections. So Transkribus is originally designed for transcribing handwritten text. The idea is that it can learn different hands, but it's also turns out to be quite good at printed text, and particularly for fonts that traditional OCR software isn't so great at, like fractal fonts and Gothic fonts. It can be trained to recognize most languages, and there's a large library of existing models that other people have made available that you can try and use as a starting point for your own model. It's constantly improving how well it does text and layout recognition. People who did early experiments with Transkribus might be astonished at how much less input it requires from you to get things going, but you can still improve the performance by training your own model. So giving it examples, correcting its examples, so that you get a model that is designed around your collection. The screenshot here is work by my colleague Adi and others. The library put some Javanese manuscripts on Wikimedia Commons. From there, they were transcribed by Wikisource contributors. And then in turn, those transcriptions with the images are being used to create a handwritten text model for these Javanese manuscripts. So there's some manual input required. There's elements of public engagement doing it this way as well, which is a fantastic collaboration across Wikipedia. And then at the end, we get a model that we could then also reshare for others working with Javanese manuscripts or apply to other manuscripts in our collection. Other uses of the British Library, there's things like popping up all the time, but we know that people have used ChatGPT to write small bits of code. So you might ask it to, how would I do this in Python? And the answer that it gives you might not be perfect, but it means that you've got somewhere to start and then you can try and figure things out from there. The UK Web Archive has collaborated with researchers like Barbara McGillivray to use word vectors, which is a method that puts words into a kind of 3D space to understand which words are close to a particular word. And you can use that to track how words change in meaning over time. You can also use that for keyword expansion. So looking for words that are close to each other in that vector space to give people something beyond the literal keyword that they typed in if that wasn't a very useful keyword for searching. Victoria Morris has done some work on language identification for print collections. So where we didn't have that information in the catalogue, she was able to predict what language things were in. And Nick Dykes has also used a computer vision API to extract text from hand-drawn maps. So there's lots of pilots and pieces of experimentation happening across the library. One of the issues for the library is, of course, that our collections are so huge that scaling anything up is a quite different matter than piloting or experimenting with things. So, Living with Machines, speaking of scale, this is a research project with the Alan Turing Institute. We began planning it in 2017, it launched in 2018 and just concluded at the end of July 2023. We worked with the Alan Turing Institute as our main partner, and with universities across the UK as well. So for the library, it was an opportunity to collaborate with subject and methodological experts. We wanted to understand the potential and the challenges of AI and machine learning and data science for libraries. We wanted to use collections that we'd previously digitized in collaboration with the British Newspaper Archive that we'd always theoretically had access to, but hadn't ever attempted to use at scale. By the time the project finished, I think the British Newspaper Archive was up to about 66 million pages of newspapers. Not all of those were used in the project, but it gives you a sense of the scale that we were looking at. It's petabytes of data. We also wanted to understand the copyright issues around text and data mining and AI, both in terms of what data we can access, what tools we can use, how that works with third parties like the Alan Turing Institute, and also how we work with derived data that comes out of those processes. We had a mixture of open access or public domain materials that we had copyright cleared, a material that was sort of so old that it's considered safe in copyright terms, as well as material that is still under license by another party. We also wanted to understand the logistical and pipeline issues in working with digitized collections at scale. So just moving files around has a certain amount of overhead. Having somewhere to store things, managing the cost of the Azure systems. It gave us a chance to think through issues like that. And it also let us see the impact of AI through the lens of mechanization in the 19th century. So reading newspaper accounts both in close reading and using distant reading methods of the impact of mechanization let us pull out threads of how people feel about AI now. So AI and mechanization both changed not only how people work, but how they lived, kinds of recreation available to them, where they lived. So it was a nice kind of meta case study of what happens when we're living with machines. And I just wanted to point out that the team it's huge. We're not the only ones doing this. We had 6 or 7 of us based at the British Library, 6 or 7 roles based at the British Library, with a number of people in those roles over time. And I think over time, the project team has had 45 people come and go. And at any one time, it had about 25 people. So it's a really, really huge project. Some of the AI methods that we've used within Living with Machines or developed within Living with Machines, a lot of work on analyzing text, and I'll give some more specific examples later, but a lot of natural language processing, computational linguistics methods, and work with large language models. And large language models are really just like those models that, text models where it's ingested as much content as it possibly can. All of the internet, as some people say. To develop models of what comes next in a given sentence. Using linguistic research methods to find instances where machines were given human-like agency, and looking for semantic shifts in how particular words changed over time. Also looking at contextualizing digitized collections and the overall newspaper collections using Mitchell's press directories, which were guides to newspapers and periodicals in a given year. That included things like the liberal or conservative leanings, political leanings, price points, distribution, to understand how representative the digitized corpus in the British Newspaper Archive is for all the newspapers that were printed at a particular time. We also used computer vision methods to read maps. So we trained software to understand Ordnance Survey maps, and I'll show you that in a second. Machine learning to improve search results, even through articles that had poor OCR, because one of the issues with the British Newspaper Archive is the project has been going for such a long time that modern OCR is relatively good, but earlier OCR is really poor. OCR quality varies according to the quality of the paper and the quality of the original print in the physical item, as well as the digitization methods. And also article segmentation has changed over time. So we're trying to work around those constraints and improve performance there. And we also did some human in the loop experiments. So we used crowdsourcing to identify as an add or not task to look at whether something or not was an ad or a piece of prose from a news article. And the idea is that we'll scale up that process of distinguishing advertisements from news stories, because whether or not you include advertisements affects the results of the analysis that you get. So that was a way of dealing with the poor article segmentation from the original digitization. So I mentioned teaching computers to read maps. We were working with Ordnance Survey maps from the National Library of Scotland and from the British Library. And people in the project manually annotated tiny patches of Ordnance Survey maps with whether or not there was any visual evidence of railway infrastructure, so sidings, yards, tracks. And then they trained a machine learning model using those manual annotations and then predicted other rail infrastructure. So they were able to scale up their inquiries to look at rail across the United Kingdom or across Great Britain. The red patches on the map on the left are actually, the red lines are actually made up of little patches where rail infrastructure has been identified. And then quite naturally, that sort of also shows where railway lines and railway stations go as part of that railway infrastructure identified. This work could have been done manually if you had a lot of time and a lot of people, a lot of patience. But of course, it's much, much easier to do it with machine learning. And this method of working with computer vision has been adopted by scientists in other domains as well, because it's quite effective at teaching computer vision software to understand visual artifacts for a specific kind of query or a specific form of interest. The team developed a tool called DZ Match, which does fuzzy string matching. So tries to help with finding particular search terms, even when the original text is quite poor because it's OCR. And it can contribute to other tools such as linking between records, doing toponym matching and things like that. So we've built on this tool, but also shared it so that others can use it. And one of the ways in which we've built on it is toponym resolution. So finding place names within text, disambiguating them and locating them. So Newtown, there's a few of those around. Working out which new town is being mentioned based on other tokens or other mentions in the text. And we've experimented with using this with crowdsourced data as well, with looking at newspaper articles to understand where accidents involving machinery were mentioned in relation to the location of the newspaper that was talking about them. So it's a method that has many, many applications, and we're excited to see how people apply this as we get to share more about it. And this is very hot off the press, an article that came out last week with the people mentioned looking at training a large language model, which they've been working on for a while. BERT is was probably state-of-the-art large language model before the release of ChatGPT. They trained BERT on digitized books from the 19th century, digitized in the British Library, they're often called the Microsoft digitized books, and created a model which internally they called BLERT, for BERT, looking to explore how language models could be used in historical research, so getting beyond keyword search. And they particularly developed a method for figurative search. So they were looking for figures of speech in 19th century texts that portrayed machines as being self-acting or automatic or alive. It's the kind of thing that keyword searches would be a bit hit and miss for, because you're not looking for a single word alone. You're looking for phrases that have that effect. So there's a blog post there that links to the article as well. So some of the concrete effects of planning living with machines is that even from the moment we first started thinking about it and from the earliest development of the large language models and neural networks, so some of the early breakthroughs in machine learning that suddenly improved machine learning's ability in about 2016, but particularly from 2017, as we began planning living with machines, we started including more AI, data science, machine learning material in our training program. So things like our Hack and Yak, sort of self-guided or hands-on 2-hour workshops, our formal training program, in the kinds of talks that we invited for the 21st Century Curatorship series, and in our digital scholarship reading group. And that's partly so that we had a mixture of skills development, but also critical thinking about AI, understanding the impacts in terms of climate change and the carbon footprint of training a machine learning model, AI and ethics, AI and racism, how it relates to work in decolonization, and things like surveillance capitalism, so how AI, ad networks, and personal data become implicated. And we also set up things like attending external courses like statistics for librarians together, because that kind of digital literacy in terms of being able to understand the outputs of the models and understand whether a result is significant or just sort of noise becomes really important at some point. So some of the lessons from living with machines so far, the only constant at the moment is change. So some things that we tried to do early in the project and even halfway through the project that were just not possible then are probably possible now. And in some ways we spent 5 years learning how to do things the really, really hard way. And more recent improvements have meant that there are easier ways of doing things, but hopefully the lessons and the tools and the methods and the workshops that we've created along the way will help others do things. So one example is we digitized parliamentary acts to do with roads to look at the impact of mechanization on transport networks. We hoped that we could get structured metadata from the page layout, but a combination of just enough variation in the layouts of the page so they were consistent for human viewers, but not consistent enough for computer vision, difficult fonts. But now Transcribus has a tool that would probably actually do this quite well. And I'll show an example later of how someone's used ChatGPT to get structured data from unstructured text. So we could probably do this now, but we couldn't do that a few years ago. We found that researchers really struggle to understand, just to get their heads around the scale and complexity of the collections of the British Library. And that's fair enough. It's a really large, complex institution. And also understanding the impact of previous collecting, so how our collections came together, the relationship between like the Burney newspaper collection and the contemporary newspaper collection, previous digitization decisions and partnerships and relationships, and our understanding of copyright. The UK has got a complex copyright environment at the best of times, and with the scale of the library's collections, it gets even more so. It's hard thinking about the differences between what academics think infrastructure is and what libraries think infrastructure is. Research projects tend to be on soft money, they're short-term. Libraries tend to think ideally in centuries, but certainly about keeping data, processes and documentation alive in the really, really long term. And we think differently about who our users are. So those were some of the kinds of different ways of thinking that we had to negotiate through the project. But we have been able to offer reusable data sets and methods that can be adopted by libraries and other institutions. I say libraries, I always think the British Library is half archive and half library. So thinking really broadly about who might use these tools. We're putting everything as far as we can onto the British Library's research repository. Things are also on Zenodo and conference sites and other places where they'll naturally find an audience. And we try and turn all our outputs into talks and hands-on training and working internally in the project to experiment together and increase literacy in different methods, and also bringing that into the library. And from the library's training program, bringing that out into the GLAM sector more widely. And really sort of taking on some of the lessons from the digital scholarship training program at the library, we found that offering a range of different opportunities helps. And I think also hearing about some of these methods a few times in different ways helps people really understand them. None of this is rocket science. I think people who work in libraries and archives are always really good at thinking about structured data. So we're well placed, I think, to understand these methods and to help the public understand how AI might change what they do and how they access collections. And some of the bigger kind of meta questions as libraries and archives and museums develop tools to improve their metadata, and as commercial vendors build that into what they're offering as well. And if we're starting to generate metadata that hasn't come from trained catalogers, but comes from software making its best guess, and how do we responsibly incorporate that into our public offer? Sometimes the ambition is to be as good as Google, but actually Google isn't that good anymore because it's full of SEO, search engine optimized, search bot generated content. Sort of notoriously for things like recipes, it's hard to find a concise recipe because people pad things out. So working with machine generated content is a constantly kind of tricky area. So switching to thinking about other examples from across the sector in digital humanities, I thought particularly things like Pixplot, and there's a lot of tools from Oxford's Visual Geometries group as well, that can help find similar images in different ways. So what the machine sees in terms of what it thinks is similar is kind of interesting. There's a cluster in the middle of like turbans, but different kinds of like headshots and fashion. This is work coming out of Yale, looking at the front covers of Vogue over time. And there's also this from an experiment from Carnegie Mellon University Libraries, where they had these really vast collections of unlabeled images and lots of duplicates. And there were kinds of pockets of the collection that had been sort of keyword described a bit. But even just like finding your way into material to start to describe it was quite daunting. But it meant that they weren't using the full range of images that they could have available for different teams across the libraries and across the university who might want to use them for marketing or for history or whatever. So they developed this tool to find similar images and also let them add descriptive metadata tags in bulk. So it wasn't only that you could see things, you could also like update the catalog at the same time. And they've documented that in a white paper in this code as well. You might have heard of Sweden's National Library having done some work with AI. They've put 500 years worth of Swedish texts into AI models working with NVIDIA, with the idea that they're supporting humanities research in a range of different disciplines. They're sharing those models on a site called Hugging Face, where you can share your machine learning models. So you're kind of sharing your statistical models. And from there, someone else can import a model from Hugging Face and train it or use it locally, or use it with the collections online as well. So it's a new way for libraries sharing the kind of the work that they're doing. And their dream is that it will enable really granular search, and I think give Swedish cultural heritage or Swedish heritage a bigger presence online than it would previously have, because notoriously a lot of these tools are developed in North America, particularly Silicon Valley, and they have a very particular outlook and set of sources that they use. So even a language like Swedish, let alone minority or minoritized languages, don't have as large a presence and don't have as many resources available for machine learning and other tools. You might have heard of this, and if it's just sort of reached a version 1.0, which is a good milestone for them. It's trying to automate the process of subject indexing and classification. It's not perfect, but you can start with one of their models and then train it on your particular material to make sure that it does meet your needs and works with your vocabularies. So I'm curious to see how tools like this affect the work that people do, where hopefully we are supplementing what people do and not in any way thinking about replacing specialist staff. This library from the State Library of Berlin, this project, I think is just a really nice example of a library taking a very grounded approach to trying to work with AI. So they're exploring these different methods of document analysis, image detection, layout analysis, image similarity search, subject indexing, entity recognition, but working with their subjects, subject specialists, and respecting their expertise, and also thinking hard about what they can make available from this process, the kinds of ethical issues that they're going to come up with, and thinking about across the history of their collections where there's problematic holdings and how they'll deal with them, and sharing those reflections as they go. So it's just a really nice, solid approach to doing this kind of work. Here's an example from the very exciting days of ChatGPT, sort of around October, November, December, when people were really getting stuck into what ChatGPT could mean for the future of research and for working with data. Matt Miller worked really hard to make ChatGPT just look at these journal entries, to pull out structured information like entity recognition, like people and places, dates, and never kind of add in bits. So only looking at the text that is literally on the page and not kind of hallucinating text. But it's a really nice example of how you can turn unstructured text into structured data, and make things more discoverable or a bit more usable in different ways. And finally, the Library of Congress have done more extensive work on human in the loop, and written a report. They used historical telephone directories, and it's a great example of the kind of resource that can be really rich for particular kinds of researchers, but because of the scale of those collections are hard to kind of use. So they've written a report as well. And I can share these slides so you can grab the links as well. Thinking about some of the challenges, and I think particularly this is for rare books and special collections, you can't process texts or images that aren't digitized. You can do some interesting things with metadata, but digitization is really key to making the most of these collections, because machine learning models are built from text or images, and it's difficult to go really far and to do kind of deep mining without access to some form of digitized images. GLAM collections can be quite large in sort of cumulatively, so that means that putting them on a cloud storage for compute, so running machine learning, can be quite expensive. So I think there's a lot of value in collaboration across the sector and sharing work that we're doing, so that everybody's not starting from scratch and trying to manage their own costs and the skills and the resources required. But I think more importantly, AI is not great at rare or special. This is a lovely post where there was a giraffe that was recently born that had no spots. And AI people love giraffes because it's just always been a challenge for computer vision to recognize them. And a giraffe without spots is maybe less recognizable. But this post, just the phrase, it says AI tends to sand away the unusual. And I think that's really key, because it gives the most plausible answer, the answer that's most likely to be accepted by a kind of non-specialist. That's not necessarily the most correct answer, the most specific answer, the most interesting answer. So I think that's one of the most, the challenges that we have in thinking about rare books and special collections, is that AI is not designed for those at the moment. And I think we'll see models that are developed around that. But it's probably not something that any one library or institution can take on by themselves. And then we have ethical issues around, do these tools really have the right to scrape the images that they did? So on the left is a real Getty Images photo of footballers, and on the right is a reconstruction that's at the center of a court case with Getty, because you can see perhaps that the image generation tool has put in a Getty Images watermark because it thinks that that's what photos have. They have watermarks. And Getty are making the case that they probably have scraped the images without permission. But I think also we need to think about whose lives and stories are being represented in these tools. So these are all versions of weddings across the world and across time. Whether or not they're recognized as being weddings in the same way that a kind of stereotypical bride in a big white meringue dress would be recognized, is something that is still being worked on. So when we talk about AI not recognizing the special or the rare, I think this is one of those cases where whole cultures don't have the same presence in AI tools as others do. And I just really like this chart about whether it's safe to use ChatGPT. And I think if you have a lot of resources to check what it's done, then it's okay. But if you don't have resources, then you can't just rely on ChatGPT, because the consequences of getting it wrong vary, but are often not great. And again, we're seeing also what generative AI, misinformation, deepfakes might mean for trust in content, and thinking about the roles that collecting institutions have in helping people understand the provenance of the images and items in their collection. That gives a trail of creation from the physical item to the digitized image, or from the camera to the image on the screen. And I think we also need to think about what search bots might mean for libraries. They're not necessarily concerned with like accuracy 100%. They might scrape material and then represent it out of context. And the search engines are increasingly trying to keep people on their page and not send them off to the website. So what does that mean for libraries and researchers? If queries are answered sort of before anyone gets near a reference librarian, or near an archivist. And a lot of industries are grappling with this change in terms of what does it mean if no one is sent to your website. But I think for institutions that have developed expertise, to not have the expertise used is a challenge too. But there are opportunities. It can really improve search and discovery. One of my favorite things to do is to go to a party or something and someone's like, oh, British Library, your catalogue is impossible. Thank you. Yes, we know. But tools can make it easier to find things that you know are in there somewhere. We can identify people and places and concepts, and we can think about servicing those in catalogues and supplementary systems, as well as doing better text transcription, recognizing page layouts, maybe even offering things like translation. So there's lots of opportunities, but there are challenges as well. But just two small ideas for what we do next. I think the most important thing we can do at the moment is say, what do you mean by AI? When someone starts talking about AI, we need AI. This tool has got AI. What does it actually mean? Where did the data come from? How was it trained? What are you doing about biases? If you are asked to do something with AI in your institution, it's important to know what it is that you're actually trying to solve. Work with people who understand the technology, think about how you can manage biases. And for any of these tools, you have to try them and sort of see what they do with your collection. And I think that's a really important part of increasing AI literacy as well. You can work on your own or work together to try these tools, upload some images and see how they are classified. And there's lots of library-specific resources, or GLAM-specific resources. IFLA have a list of 23 resources. There's the AI for LAM community and many, many others. And of course, some of the talks that you'll hear across the conference as well. And I think we also need to think about how AI is being marketed to other departments across the institution, and what that means for us as people whose data is being shared, but also for our relationship with library users and with others. So I'll stop there and I'll say thank you for listening. And I would be really happy to have any questions.
Thank you so much, Mia. That was excellent and really fascinating. Thank you so much. It was kind of right up my street, managing to be about 19th century collections and railways in there. So it was really enjoyable for me. I was also really a little bit shamed by all the people in the chat who had popped in the things that they had used, and I was suddenly thinking, I need to start using these things as well. So I want to invite anyone to who would like to add questions in the Q&A, and I can see there's already some there. So I'm going to just kick off rather than using my chair privilege to ask questions. So here we go. Mia, thank you for a fascinating paper. You mentioned learning things the hard way due to the length of the project. Can you say more about the difficulties and mitigation when things are developing so quickly?
Yeah, it's I mean, I suppose in a way, having spent a lot of time saying AI is going to be really important and is going to change how we work with collections, I can't be that disappointed that it did change how we work with collections. But in some ways, it feels like we spent a lot of time like building tools and working out processes. And then someone comes along with like a little glue tool or a little software library or something that makes it a lot easier to do that work. So it's kind of like you've walked up a hill and then someone goes up on a zip line or something. I think because of the way the project worked, we were working in a quite agile way, but if you sort of stopped whenever there was a new technology and tried to jump on that, then you would actually get nowhere because there's been so much change over time. But it is also, I guess, just a fact of life that if we did it now, if we started the project now, it would be really different because we'd be starting not only from like 5 years of normal development, but like AI time is kind of like exponential. So it'd be sort of starting like 50 years ahead of where we were when we started because the technology has just changed so immensely in that time. And the capabilities of what it can do have changed so immensely in that time.
Thank you, Mia. That's great. So another question from the Q&A. Could you reflect more on ethical approaches to, e.g., decolonization and problematic languages when humans or librarians are often finding it difficult to establish approaches and what to do?
Yeah, I think it's one of those situations where you can't leap into text solutionism. You can use search methods to find terms from a list that you might think are problematic, but software can't determine the appropriate choice or the appropriate substitution. You need people to actually look at the items and make judgment calls and ideally kind of do those in a way that's shared across the sector. And in some ways it's difficult for the sector to have a conversation about this because of the way that it's leapt on and derailed, where we're just trying to make descriptions suit the times better because a lot of cataloging and a lot of subject headings were devised some time ago and they're not really appropriate for now. But thinking of it as tools can help you with the process. They can help you find problematic labels. They can help you find, understand what's happening in images or in texts, but they need to be part of a wider policy and a wider set of decisions about how you're going to handle those, and where you might use different subject headings or work with the institutions that manage the subject headings to improve the labeling there. So the software itself is only a tiny part of that overall process, I think.
Great, thank you. I believe we have someone with a hand raised and my colleague is going to unmute them so that they can ask their question. Anybody there?
Ella should have the ability to unmute now.
Was that Ella, Rich?
Keller.
Keller Lawrenson. If that's not working, Keller, you can pop something into the chat or the Q&A. Lucy, we have another question while Keller's...
yeah, I'll go to another question. Sorry, so that was an accident. Sorry, Keller, for spotlighting you there. So another question in the chat is, to what extent should libraries and archives be leading on AI when it seems government is at risk of getting left behind?
Yeah, it's tricky. I think leading on AI, there's many different ways that you could think about that. So any large collecting institution has probably had approaches from companies wanting to mine their data. For the library, as you know, we obviously have like contemporary journals, legal deposit, e-deposit books, but a lot of our material that's digitized and copyright free is 19th century or earlier. And I don't think it's really healthy for a society to train models. You can train models for historical research, but you wouldn't want to train a model to think as the 19th century writers did, because that's not great. But the lessons that you can learn by playing with those data sets that are more easily available, that are kind of interestingly messy. So I think work that we do in digital scholarship and BL labs in encouraging people to access those data sets and use them, and hopefully using the tools from Living with Machines and other projects gives people a space that they can experiment and try things out using material that's kind of quite sort of materially different than training things off Reddit or off Facebook or whatever else. I think the government has an opportunity to lead in AI ethics and the sort of practical applications of AI regulation. And I think libraries and collecting institutions are quite good at thinking about privacy, patron privacy, access, community engagement, and understanding, particularly things like public libraries or university libraries have got very specific views on what they know people want from those institutions. And I think that would be useful for government in thinking about what AI could be, because it's very practical. It's not kind of, you need both. You need that, like what people are trying to do now, an understanding of what people want to do with collections and research and creativity and enjoyment, as well as the hand-wringing / hype that comes out of Silicon Valley. So I think we all need to be in that conversation. And I think maybe libraries as mediators of civic discourse could have an important role there as well.
So I've got a question from Bob, which was actually very similar to the question that I was going to ask. So for an administration that is resistant to experimenting with AI tools, how would you suggest that staff negotiate with administration to allow them to experiment? And I guess that was quite similar to my question in a lot of our delegates here today might be from very small libraries where, you know, they're one person or there's no funding available for this kind of thing. So it'd be interesting to hear what you think about that. And they also ask if there's any kind of email lists or social groups where those who are active with AI congregate and discuss projects.
Yeah, the AI for LAM community is has a Google group and a Slack, and they have regular community calls, and the community calls can be a good way to just dial in and listen to presentations from people who are working on really specific things. It can be really hard to experiment. It's AI for LAM. But also I can share these slides with the links in. There are a lot of MOOCs, so multiple like large online courses, and you can try out some of these tools. So we've got various Jupyter notebooks that you can run on someone else's cloud for free, and things in Jupyter notebooks, they have a bit of text and then you sort of press a thing to run the code. So it's a good way of learning and experimenting without needing to install anything, without needing your own data. You can use Google Colabs to run things as well. So there's various ways of kind of doing things in a kind of scrappy, patchy way for free. There are lots of cultural heritage data sets around that you could use as experiments. If you can't access your own material, you can find collections that are like yours and try out methods. There's also Code for Lib as a discussion group and kind of community. There's the museum's computer group. And there are probably various meetups as well where people are kind of doing more of the pure tech side of things. And you can also use some of the computer vision tools. I have like an old tutorial from 2015 that just goes through how to try, like upload an image to these various classification tools and see. Yeah, I think I did actually have a slide on like where to get more, and I took it out just for time. But yeah, just trying out some of these tools and reflecting on them, or doing things like a lunchtime session where maybe you and some people who want to try things out get together. And maybe if you know people from other institutions, you might be the only one in your institution who's interested, but if you know someone else from another institution, like get on a Zoom call together and try things out and just sort of see what happens. And at the library, we're trying to do more with the digital scholarship training program to share more of what we've learned with people, because it's great that people in the library get to learn with this, but we really want to make sure that we're enabling as much literacy and learning across the sector as possible. So we mostly post on Mastodon now rather than Twitter. So I think the slides had the sort of the Mastodon handles, but the digital scholarship blog and the Living with Machines blog both have the kind of latest stuff that's coming out of the library.
Thank you so much. We're kind of out of time now. There's a couple of questions I didn't get to in both the chat and the Q&A. I don't know, maybe Mia, you have time to answer them in text at some point. Or I'm sure that if people have further questions, they can maybe get in touch with you directly. So it's just down to me to say thank you again to Mia for joining us for our keynote, and so thanks on behalf of the RBSCG and of the delegates. I'm going to pass over now to Alex Kiver, who is going to be the chair for the next session. Thanks again, Mia.
Hello, so yes, I'm Alex. I'm the secretary of the RBSCG, so you can send any complaints or compliments to my email address. And I will be chairing the sessions this afternoon. So we have 3 sessions this afternoon, all on the subject of digital technologies. Each of our speakers will present their papers for 20 minutes, leaving 10 minutes at the end for any questions. As with the previous talk, please do put all of your questions in the Q&A function down here. And yes, so moving on to our first paper and introducing our speakers. Maciej Pawlikowski is head of the Digital Content Unit at Cambridge University Library, leading various digitization projects to populate the Cambridge Digital Library with an average of 150,000 digital assets each year. He is joined today by Raffaella Losito, a multidisciplinary creative whose work focuses on digital preservation and cultural heritage. Raffaella has worked on several significant digitization projects within the Cambridge University Library. Together, our speakers will be presenting their paper on 2 decades of digital photography in the library, the evolution and practice and technology.
Hello, good afternoon and dzień dobry. I hope you can all see the presentation now. My name is Maciej, and together with my colleague Raffaella,
Hello.
We will reflect a little bit on how the photography practice have changed over the past 2 decades. And we'll focus on the libraries and archives, and in particular on digitization of medieval manuscripts, because this is what we brought as an example to show that. This presentation is a bit of a self-ethnographic take on a subject. There is no way to avoid technical terms, but we will try to explain them as well as we can. And there is no also way of avoiding talking about the equipment, photographic equipment, and because that was one of the main drivers for those changes we'll be talking about. And we will also attempt to present these topics in the comparative study of images way and draw wider conclusion on both technology and the knowledge investment in the field of cultural heritage digitization. Now, this picture you can see on the first slide is the studio from the first digitization project I took part in 2005, Park on a Web, in Corpus Christi College in Cambridge. And in some ways, it was similar to the early days of digital image archive of medieval music. when Dr. Julia Craig McFlee with her team traveled the world to capture preservation quality photographs of selected manuscripts. It happens that she also visited Bodleian College in Cambridge to digitize Pepys 1236, the same one, the same book which we decided to photograph for Curious Cures project in 2023, so this year. Yeah, and Curious Cures project is Wellcome Trust funded to digitize, catalog, and conserve over 180 medieval manuscripts that contain unpublished medical recipes. In the case of Pepys MS 1236, this one contains 119 pieces of musical scores from 9 different composers. So it was in the interest of the DM project. And also calendars, poems, health remedies, and astronomical tables, which were interesting for our project. So today we'll use this manuscript in particular as a case study to example some of the points of the presentation. But to start the discussion about the camera equipment, to start this journey, let's talk about what it's called digital scanning back. This is the piece of equipment which DM project used for in early days to deliver the images. In a way, this kind of equipment is similar to a flatbed scanner or the photocopier, because it has this sensor which is linear, which means it takes the one line of pixels at a time and compiles it as a one image as the sensor moves across the scene. And these have certain advantages, because in early days of digital photography, that was the highest possible resolution you could have. But on the other hand, it has some drawbacks as well. One of the most famous, and this is why I think we're under a great impression of the DM project as well, is that these machines were very prone to vibration. So any kind of move on the wooden floors in different libraries that could cause a lot of problem. The DM project people, they traveled all around different places, different environments, and that was must have been quite difficult to make it happen. Now, in the early days of high quality digital photography, the equipment was really kind of a crossover between analog and digital. It wasn't fully digital. So this is the example of the camera, which is a specimen we have in University Library in Cambridge. And this is specialist copy stand camera. It's quite big, as you can see. Well, can you see? No, probably not. The scale at the bottom here, that's 35 centimeters probably, and 40 on the tall side. So it was quite big and heavy, weighing over 5 or 7 kilograms or so, but it had certain components like the lens and the camera body, which were purely designed for analog purposes. Now, in that viewfinder, or where there are marks of kind of a target and grid, that would be used to preview the scene before the photographer takes the image, and only after that's set up, they could slide the cartridge with the film, or even the Polaroid sensitive sheet to have a quick preview of the image. Now, in early digital years, they would use those scanning backs. That's the very similar scanning back to the one we showed before, but from different company. So just to say, these cameras and lenses used in the early days of digital were really designed to be more analog than digital. And that would have some visible signature and differences on the images, and something we'll come back to at the end of that presentation. Now, nowadays cameras are much more sleek, well designed, with nice buttons, very quick electronics. Whatever we take as a picture, it takes literally instance of a second, and it's quickly visible on the monitor. You can preview it, you can have a live view and the other features which really help to work with images. And of course, that change didn't happen overnight. He designed this infographics to kind of map all the photographic equipment available for the last 20 years and kind of differences in it. So the digital scanning bags we're talking about in the early days, they are somewhere here as well. And the introduction of the single shot medium format cameras with larger sensors, large enough to actually be helpful in cultural heritage kind of digitization projects. They only came later on. And they've been constantly developed to what we know right now. And the striving for the large sensor, large image, and a lot of pixels was something which is very important for cultural heritage because of the reproduction of detail. Raffaella is going to talk about it a little bit more in a minute as well. Now, the cameras which were widely available off the shelf and not maybe as expensive as the high-end digital bags only came to play later on when kind of technology developed a little bit further. Now, as we are now, I think we can design a system pretty easy without as much expense as it used to be. So it's much more available in the to achieve for any kind of institution. Now, one of the most important things that over the years of digitization is the increasing knowledge of digital as such and the standardization of the cultural heritage photography. So those little red triangles, they are quite important here as the consecutive standards which came to play over the years. Before that, we just had the kind of idea of the principles we should be using and something which would be considered a good practice, but not really standards to adhere to. So what we also learned over the years that digital image is as an array of numbers which somehow computer displays as a photograph. But also the good thing about it is that they are they can be measured and calculated using very scientific methods. So the color charts like this, you can see on the slide here, they help us to achieve that. However, image quality has many characteristics which are important. And for instance, those on the left, they are mainly dependent on the camera equipment we would be using and how we set it up. Now with the ones on the right in red, they would be highly dependent on the photographer's knowledge, skills, the protocols they use in the studio, and they practice. And now I'd like to hand over to my colleague Rafa, who will tell you a bit more about how those practices compare to those from early 2000s.
Hello, everyone. I'm Raffaella, and I'm the project photographer for the Curious Cures project. So in these slides, I'm going to quickly show you the differences and the similarities in the photographic processes between 20 years ago and today. As you can see from this picture, when we take images of a manuscript, the most important thing is the station. So nowadays we use photographic cradle that is being designed from a conservator, which is the best photographic station at the moment to take pictures of a manuscript in a safe way. So the main principle of cultural heritage photography are consistency, accuracy, and a good detail reproduction. And in order to make this happen, we need to make sure that the photographic environment is good for it. So as you can see, we have no reflection from the wall of the ceiling because they are painted in gray, and there are no ambient light interferences. So to prepare the lights, we make sure that these are 45 degrees to the opposite side in order that we have a consistent and uniform light towards all the photo session.
So compared to the DIAM project, now for us, we could say it's much easier to take pictures of the manuscript, because we don't actually need to move our equipment, but it's the manuscript itself that comes to the photo studio. So, but it turns out that the basic photographic principle, they are very similar between then and now. So one of the most important characteristics of cultural heritage photography is the reproduction scale accuracy. So how can we explain this? Basically, we need to understand how many pixels we can have to reproduce the object itself. And this is dictated by the size of the camera sensor and the distance of the camera to the object. So like the DIAM project, we make sure that the shooting surface is at a specific distance to the camera to create an accurate detailed reproduction that is at 1:1 scale, and which is defined by pixel per inch, or PPI. Here we can see how in practice the differences in pixels can change also the dimension and the size of the image itself. So in a case study of 600 ppi or 300 ppi, we would have either 15 by 10 inch or 30 by 20 inch. So the main imaging principles that we follow today, they are very similar to 20 years ago. And going more in deep, you can see here, at the time, the DIAM project, they didn't really have standards, but what do they do to create as much good quality images as possible? They were putting the camera as close as possible to the object itself, so that it was covering all the frame of the camera. And in other words, this means that they were shooting in 1175 pixels, which is almost double the size of what we do today with 750 megapixels. So in other words, we can say that DIAM was using the best possible resolution at the time, and this turned out to be a really good choice for the future. Now, for the digitization, obviously, the workflow is a very key moment, a very important moment, and it's a big thing. So the first thing we do is the calibration. So we can explain the calibration by a series of action and procedures that teach the camera how to reproduce the object in the most original way, so that the object is represented with the true colors. And in this step, we can say somehow that our approach as a cultural heritage photographer, it's very similar to what used to be the analog photographer approach, because we try to have everything in place at the start, so the post-processing is kept at the minimum. So we only have to do the cropping, the minor adjustment. And after this phase, we will have the quality check. So the last phase would consist, for instance, in checking the file naming or the metadata and all the this kind of information. Last but not least is to consider that we need to make sure that all this effort is preserved and that we work in a color managed environment. So this means not only having a camera and lights that they are color managed, but also we use calibrated displays and photographic softwares and digital preservation storages, etc., etc. So this allows the photographer to examine the results, but because all the imaging standards rely not only
on the machine measurements, but also the visual assessment by a skilled photographer. So both the human and the machine, they have to cooperate to in order to make the color assessment looking great. Also, we are using file storage solution, which supports the right file formats and color profiles. So as an example, it happened once that during a file migration, some of the color information went lost. But thanks to the color chart images that we keep in our archives, we were actually able to retrieve this information. And this all comes to from a good practice in the workflow. So now I can hand over back to Maciej, who is going to show you in practice some example of the images of the.
Thanks, Rafa. So how the images compare? Well, they compare very well, actually. You can, as Rafa mentioned, the resolution and detail reproduction used by DM was far exceeding what we would expect nowadays. And obviously the cradles make more pleasing images because it's much easier to work with the manuscripts, and they are basically maybe nicely laid out. But what's there are minor differences in things like tonality, the variation of the tone reproduction, and the way the texture and parchment look, and how the ink looks, and overall there is slightly different contrast between the images. So without going into too much details in all of those aspects, I would just focus on one, which I would like to talk about, and because it's important. We learned quite a lot of that from those early projects such as DM and Park on the Web. So here I try to reverse engineer this concept to explain it how in practice the equipment changed and what cameras can reproduce. So traditionally, the film photography contrast was represented as a curve. You can see that curve I reproduce in Photoshop here. And each model of the film would have their own signature based on the chemicals designed to achieve that effect. So we call this S-curve because of its shape. But it would mean that the brighter parts of the image, which are represented here, they would be even brighter, and the darker parts of the image would be slightly darker. And this is what the contrast is about, right? And quite often cameras are designed to give it this effect as it is desired in most of the photographic applications, but not in cultural heritage. Since we have been striving for consistency and accuracy and the reproduction of detail, now we know that there shouldn't be the curve. The line should be the flat. It should be linear rather than S-shaped. So there is no visual information enhanced or compressed within the image itself. And perhaps we knew all of that 20 years ago in theory, but there were not tools really available to implement and explore it further. The equipment used 20 years ago was not optimal and on the crossroad of analog and digital, as we tried to show that before. Now, for instance, the design of the analog lenses could be such that the image was appearing less sharp or even more contrasted than if you use it with digital sensor rather than the film. So that brings us to first of the conclusions that we would like to recognize the importance of the incredible digitization efforts in the very early digital era of digitization, like DIME's projects and Park on a Web. They explored the unknown territory of digital imaging, and they made it so well that it's still valid today. And the lessons learned from then form the basis of later standards and similar other projects. Now, digital collections are also the artifacts on their own right. And by photographing it again, the MS PEEPS 1236, we have created another version history of that manuscript as we needed for our project. And the good quality photography is available, was available in early days of digitization, but required a very particular set of mind and lots of investment. Not all of the cultural heritage institutions were lucky enough to explore this route in early days. But now that the technology is available off the shelf and the imaging standards are widely adopted, there is no real reason not to follow. Images can be acquired not just easier and quicker, but also more accurately. That, however, requires, as we understand it, more investment in specialized resources, the skilled photographers, the knowledge-based approach to the digitization process. And luckily, we can see those changes happening in the GLAM sector. The equipment itself is not as important anymore, but those good practices, they help to create the images which can be later reused. So for curious projects, we will use the hand text recognition, and the good quality images really help with that. Although there is this other side of which Maciej also mentioned in the previous presentation, then the GLAM images can be really large. So for instance, our 2023 versions of images are only half the size, and we know it's good enough for the purpose we need it. And digitization is more than images. We make the research happen, and the quick and easy low resolution scan might create incomplete data sets of which you need to be aware, and maybe mislead the research questions as well. Therefore, photographers are also research technical professionals whose unique skills and specialization affects the result. Thank you very much.
Thank you both so much for a fascinating talk and an incredible insight into, I guess, how much digitalization has changed in the last 2 decades. I thought it was quite incredible to see the comparison between the 2003 image and 2023 image. And actually, I mean, like you said, those early images, I mean, they're quite impressive for being 20 years old, although the resource required to produce them at that quality was far greater than what we need require now. And I guess taking my sort of privilege as chair, and please do add any questions to the Q&A function now if you have them. But taking my privilege as chair to ask a question, I wondered if you could, because looking at sort of the infographic you provided of sort of the last 20 years, the history of the progression of technology and standards over the last 20 years, I wondered if there were any particular moments, either with the introduction of a certain technology or a certain standard or practice, that were a sort of almost revolutionized the practice or overcame a significant bottleneck in the process of cultural heritage digitization.
So if I can answer this, I think that there were a couple of the moments when we got really extremely excited, and the technology comes in a certain package. So for instance, the introduction of the single shot camera, which had large enough resolution of the matrix, was quite a change. But then we realized that, oh, actually the software is not there yet. So we had to hire another person on the Parker on a Web project, for instance, just to do the image processing on a separate machine. So it just required further investment. So there were several points like that, yeah, where some things came. We really got excited about it, and then it didn't happen that quickly, you know, or like the difference between the colors, which is called delta E. I remember the times when we were using Excel spreadsheets to calculate that. Now we have the online form when you can just put it in there. You can even have the online version of the color profiler, which will give you the right color profile. So this is the essential file which is used to teach your camera to see the colors correctly if you want to calibrate it. So these are, yeah, there are several milestones like that, as you said. Yeah.
Fascinating, thank you. And on that as well, I suppose, you mentioned early on the sort of how technology has changed, and we looked at that very early example of the sort of flatbed type scanner with the sort of strip that would get the pixels in strips at a time. And you mentioned the issues with vibrations or things like that causing disturbance with the image. And then later in the presentation, you obviously showed, for example, the cradle as the ideal way of imaging a manuscript with stability. And I wondered, with a project where you were going to other institutions, possibly internationally, and trying to achieve a consistency of image quality, but perhaps couldn't obviously take a quick piece of equipment as large as, say, that cradle that you showed, what would be the standard approach to a project such as that today?
So I said there is a travel version of the cradle, which
we do have that.
We did try, and we moved it around from time to time. It's not ideal, but it's obviously much better. A traditional copy stand idea as well, but that would not. That would introduce the same issues as you would have in another way. I think the traveling cradles are the easiest in a sense, although they also expense, and they're also quite. They are not the most affordable neither, but possible.
Okay, thank you. And I'm aware of time, but I think we've got time for maybe one or two more questions. So we've just got a quick one in the Q&A. Which is asked, can you say more about how the creation of image metadata has evolved over the last 20 years as well?
So with the metadata, I think when we're talking about photography, we often talk about the embedded metadata, embedded in the file, which comes with the creation. So as soon as you press the button, should the trigger, then the center information which is already coming in to the file. And with the more whole systems, like the cameras are very compatible with the lenses. This is where all that information is passed electronically and written into the file, the EXIF metadata. In the early days, a lot of that metadata would be lost because the lens would not talk to the digital back, for instance. So unless you enter it manually, that would never happen there. And I think another change is coming with the digital library and the displays and the metadata in TEI, which is like the most flexible and descriptive metadata. So yeah, when it comes to at least like working on the transcriptions and the further lifetime of the image, this is, I think, one thing I always say about the digital libraries: the images wouldn't exist online really without the metadata. They wouldn't be searched for. They wouldn't be found in the same way. Would be much more difficult. So I think that's very important. Yeah,
and that's why it's important for the photographer to work really closely and in accordance to the digital library team as well, because it's not just that the photography department is detached from the picture library team. We work really closely, and we make sure that all the input from there and from the catalogers, they are in place once the image they are put on the digital library. So this is a very important aspect to consider as well.
Fantastic, thank you. Well, we do have one or two other questions. I'm aware that we're sort of slightly running over time, but perhaps we have time just for one more very quick question, which in the Q&A someone has asked, you mentioned quite rightly the skill of the photographer. Do you foresee this photography process or parts of it becoming more automated?
What do you think? How can we automate it further?
Well, well, actually, I think the role of the photographer cannot really be automated at the time. I mean, like last November, I've been in a conference where the AFAP conference, where they showed us some automated process for digitization, which consists on robotized arms, which were moving the print to the scanner, like in a very automated process. But still, in that case, we could see that there are lots of bugs, and like there is lots of prep to do before the digitization automated process. So I think nowadays the role of the photographer cannot be replaced from machines, luckily for me.
Not for medieval manuscripts,
No,
at least.
because we still receive very important handling guidance, for instance, from the conservators, and we work really closely to the conservation department in order to make sure that is that the items, they are treated with in a good way, that we take care of them.
So I think also that coming back to the previous opening lecture, the keynote, I think the AI or kind of machine learning engines might really play the role in the advanced imaging. When you look at we do a lot of photogrammetric models and 3D renderings, and these, indeed, the scanner we use at the back end is a cloud AI engine, which is purpose built for that, for putting the images together and creating the different objects out of the multiple different images and scans. And I think this is the area where it's really worth investing and looking into, recognizing it. Maybe simplifying a little bit of work of the photographer when it comes to, I don't know, image cropping and making some adjustments.
Yeah.
A little bit, yes. But as Rafa said, most of that is done actual photography. Before we start photography, we want to make sure everything is set and ready to go.
Yes, yeah. Well, thank you very much for answering those questions. And apologies for anyone who's asked me, which we haven't been able to get round to, but we do now have to move on to our next session. So thank you to both our speakers, Raffaella and Maciej as well. Thank you for joining us today.
Thank you.
Our next speaker this afternoon is David Mills, an X-Ray Microtomography facilities manager and researcher from Queen Mary University of London. David designs and builds CT scanners and microscopes to image otherwise unviewable objects. And the subject of his talk today focuses on the application of X-ray microphotography for reading the unreadable in special collections. Over to you, David.
Hello all, thank you very much. Hopefully you can see my screen. So my details are on there. I'm David Mills. I work in a dental school, which is a bit of a strange place for somebody who's presenting at this conference. And I'm actually a lecturer in imaging and calcified tissues. But I work with heritage scientists, and I'm going to talk a bit about digitization without disruption. So ways of accessing special collections that have been put on the shelf because you just hope somebody at some point in the future can help you read them. Hopefully I can be that person. So opening a sealed item is a disruptive process. You're either going to lose the seal or a lock, or you're going to damage the item. If it's a parchment roll that's got wet and gelatinized and solidified, you may fracture it just trying to open it. And opening is a disruptive process, whether you're doing it for scholarship, conservation, or just because you want to have a look, see what's in there. So I'm going to show some of the work I've been doing with colleagues over the last few years to start to be able to get textual content. And some of the stuff that's been mentioned about AI is actually particularly interesting to me. We may be able to use some of that. So the talk says X-ray microtomography. What is that? Well, microtomography is a microscale version of medical CT. So if you've ever had a medical CT image, it uses lots of X-rays. This is a smaller lab scale version. In fact, one of the machines is behind me. Developed in the early 1980s, specifically for looking at teeth and bones. And the systems that I currently use at Queen Mary are derivatives of the original designs by Elliott and Dover. They're not optimized for scanning big things. They're not optimized for scanning things quickly, but they're optimized to get the best possible contrast. So hopefully we can see the things that other people can't. Why X-rays? Well, a little bit of science. We know in general how we image things is we shine some light on it and look at what's reflected back. Well, X-rays are slightly different. X-rays are still light. There's no issue with them. They're not anything scary. They're just shorter wavelength light. But the difference with imaging with X-rays is you detect what passes through the object, not what's reflected. So you're effectively creating shadowgrams. The very first medical X-ray image was this one here of the hand of Bertha Röntgen, the wife of Wilhelm Röntgen, the guy who discovered X-rays. And there's just a much more modern image from my lab when I had a lamp that failed and I wanted to see why. So we're looking at shadows. Well, where does the contrast come from then? We're used to, if we're looking at objects with reflected light, we know the contrast comes from the absorption or reflection of light, different wavelengths of light from pigments and contrast media. In X-rays, it comes from what the item is actually made of. So if it's heavy and dense, for example, gold and a gold ring on a hand, you get a nice shadow from it. If it's calcium and phosphorus from bone, you get a less dense shadow, and all the soft squishy stuff, carbon, hydrogen, oxygen in the flesh, gives a fairly ethereal view. Well, what does this mean? I mean, that's okay if you want to take an X-ray of a broken arm. What does this mean if you want to use X-rays to look inside something? Well, what you need is the substrate to be a material that doesn't show up too strongly. So it needs to be paper, parchment, wood, bark, basically the things made of hydrogen, oxygen, nitrogen, carbon, the sort of stuff that doesn't show up too well on X-rays. You ideally want the ink or any illuminations to be a heavier material, copper, gold, silver, mercury, iron, the typical things used for illuminations and text in the past, which is great. But what it does mean is you're very unlikely to be able to see carbon ink or graphite on paper, which is unfortunate because there are a load of very interesting things that we know were pencil drawings on paper that have got soaking wet and formed sort of fixed masses. But I don't think we can actually work with those, unfortunately. Although there may be ways. Problem is, one X-ray isn't enough. If you've just got a line of text, great. If you can see that in an X-ray, you could read the text. But if you're looking at a sealed document or a parchment roll, you tend to get multiple layers over the top of each other, and you're trying to read text that's overlaying text, and you're trying to read text that's running in a different direction. And I think even some of the best AI systems would completely choke at this and crash. You would probably drive your friendly paleographers completely mad. So what can we do about this? Well, we need a 3D X-ray. Instead of just getting layers of ink one on top of the other, we want to put them in a three-dimensional space so we can actually trace where the ink is in space. We have 3D X-rays, so I alluded to this earlier. We call them CT scans. And a CT scan gives you a slice through a person, for example, here. One thing you know if you're having a CT scan is they don't like you to have too many CT scans because X-rays are bad in the long term. If you have too many X-rays, your doctor gets a bit worried. And we know that if you have a dental X-ray, the dental nurse wears a lead apron and walks down the corridor. The CT technician is in a separate lead-lined room. So we know X-rays can be problematic for living things. What about things that are no longer living or were never living in the first place? And if I'm putting lots of X-rays through a parchment roll, for example, am I damaging it? Well, we did some work on this in the past, about 10 years ago now, where we looked at repeated X-ray exposure to parchment after a tomographic scan. And the conclusion was we can't see any effect. There was one particular case where it was a soaking wet piece of parchment that there was a noticeable effect, but we don't scan soaking wet parchment because it's horrific stuff. So what does a machine built for doing this kind of work look like? And I'll show you what some of the results look like soon. It's a lab scale device. It's about 1.5 meters long, about 1 meter deep, 1.5 meters high, 1.25 meters high roughly. And you can sit next to it and it's safe. Inside, you have a camera, you have the item being scanned in the middle, and you have an X-ray source and the various support hardware around it. And in our particular example, we actually sweep the camera back and forth across the item being scanned, building up images in a similar way to how a photocopier works. So we have a fairly small sensor, but we can take much larger images by moving the sensor past the item being scanned. I mentioned slices. It's exactly the same as this, a Swiss roll slice. I know people working in heritage like cake, so an image of a cake to get you all ready for afternoon tea. If you think when I say about slices in the upcoming slides, you think of this, you're exactly on the right lines. You can either take a slice like this, or you could imagine slicing the cake along the long axis, but they're still slices. And all of the slices I talk about are virtual slices. We are not slicing up the object. We're not damaging the object. Once I scan it, it goes back into the archive, back into the stores. Everything is then processed offline. So when I talk about slicing, I'm really not slicing up something valuable. The first real work we did using this technique to unroll a damaged object was the Bressingham roll. So this was a parchment roll from about 1409. It was a detail of the annual accounts of the Manor of Bressingham in Norfolk in the UK. And approximately 70% of the roll is inaccessible due to water damage. So at some point the roll has got wet. It's fused at about the layer where it's no longer opening. You can see various tears in the parchment where someone forced it open before, but you couldn't force it open anymore. It's just solid. So we scanned it. It took about 3 days to image. And as a virtual slice through, so you have to imagine the parchment roll is extending in and out of the screen at this point, and the yellow is just pseudo color of the parchment, of the plastizote that the roll was encased in for scanning. We can see quite clearly the open, readable part of the parchment. There's space between it and everything else. But we can also see there's a very obvious fused region where we can't even resolve the layers. And this was a fairly high resolution scan of about 20 microns per pixel. So this whole area of the parchment was fused, and that's why it can't be unrolled. So this was useful just for conservation purposes before we even attempted to read this. The conservators could see, don't waste the time trying to work on this, it can't be done. Comparing X-ray images to visible images is really quite good. We can see areas that faded out, invisible, are still fairly clear, an X-ray image. And we worked together with computer science experts at the University of Cardiff to perform a virtual unrolling of this parchment roll. And it's published, and there's information on the YouTube video. So we were able to get quite a lot of information from this, and the historians were happy. It answered some questions they had about fishing rights and tree cutting rights on the Manor of Bressingham. Later projects I've worked on with the signed, sealed and undelivered project. So I was contacted by Jana D'Ambrosio at MIT Libraries, who knew of a particular collection of letters in The Hague in the Netherlands, of about 2,000 undelivered letters, around 600 of which were unopened. And Jana had a particular interest in the folding and the construction of letters before the gummed envelope was available. So we, as part of the long project, we managed to acquire some of the letters to come to the lab to be scanned. And we took a scan of 10 letters to save time rather than scanning one at a time. We could fit 10 in the scanner, so we scanned 10 to work on. And we can see immediately very nice detail. We can see detail of the pages. We can see evidence of ink and also evidence of sand or crushed shells, which we use to dry up ink. And we can also see that some of these letters appear to have other letters or other documents enclosed in them. They're quite complex objects and actually just quite beautiful in an X-ray image. But one of the problems is 17th century wax is full of metal. They pigmented their sealing wax with lead and iron oxides and things, which casts horrible artifacts through the CT scan. So we needed some experts. So we were contacted, as I say, by Jana, who knew of some other people at MIT who were interested in this project. And we ended up with Amanda Kasai and Holly Jackson working on the project, who were able to take our CT data of the letters, run it through some very, very good software they had developed, and actually virtually unfold the letter. So as well as be able to read it and show where the ink is and actually produce a transcription of the text, they could produce an exact map for how to fold that letter up, as the animation is shown here, which I've seen this so many times, I still find it mind-blowing. So this was published a couple of years ago now, and all of the data, all of the algorithms, everything for this is open source and is all available online. If anybody really wants to work on the software for this, it'd be brilliant. I think it could be adapted a lot further. And to bring things more up to date, this is a current work in progress, literally hot off the scanner behind me last week. So this is from the National Archives of Ireland. It's a King's Bench roll from 1406, 1407. It's one of only 2 records which are known to have survived from damage to the Public Record Office in Ireland in 1922. So it's in particularly bad shape. We can see it's parchment. We can see there is some text, some writing on it. It's iron ball ink, so it shows up nicely in our X-rays. But we can see it's been through the wars. But if we scan it, it's actually in pretty good condition internally. We can see the wooden dowel. We can see the thread, which is tying the parchment bundle to the dowel. And the brighter areas, which can be seen throughout this, are ink, which shows up quite nice and clearly. So I've been doing some very, very rough work. This is Friday last week, to actually see, can we read anything from this roll? So using some flattening software, which is basically given a section of this curved parchment in 3 dimensions and attempts to produce the flattest surface, we were able to start producing some text from this. I've not yet attempted to read this. I think it's in Latin. I think Jessica, who may be in the chat, may be able to correct me if I'm wrong on this. But we can see the text is amazingly really clear. The bottom area is where the software has gone slightly awry and can't work out where the flat surface is. but there's more to be done on this. Another section where the text is really quite clear and almost readable. So just to kind of wrap up, I may come on to one more thing, which I think some people find interesting. Technology is rapidly developing ways to produce digital surrogates of items that cannot or should not be opened. The technology isn't totally widespread yet. Certainly some of the things I've shown here can be done in my lab. They can be done in a few other places around the world. I think we still have the edge on the contrast resolution. So if you want the best of the best, we can probably help you. Please consider alternatives to opening items. If you find a big chest full of sealed letters, please don't just rip them all open. Talk to somebody first and we may be able to help you. And sometimes you may just have to disrupt items to save them. So is there anything I can help you reveal? This is a plea for, please contact me with your weird and wonderful item that you want to see inside, and I will do my best to help you. Some acknowledgements, but I'll come back to this because I have a couple of minutes to go. I'll just show one of the other things from a special collection that's not parchment that I find absolutely fascinating. This should not have worked as well as it did. Cinefilm. And this is where disruption is sometimes totally unavoidable. This was Morecambe and Wise Series 1, Episode 2. It was originally recorded on videotape, which was then transferred to Cinefilm to be shipped out to shown overseas while the videotape was wiped. The film was supposed to be destroyed after being shown. This was found in a shed in Nigeria. It's a telecine print, so they literally pointed a film camera to a TV screen and recorded it to film. The film can had cracked. The conditions it was stored in were terrible. The film had started to turn back to vinegar. It's acetate film, so it degrades back to vinegar and cellulose. And you can actually see here, it looks quite sticky and awful. There's no way you could actually get this through a projector to digitize it. So we had already shown that our systems could image cinefilm. We'd done a very early project where we just looked at a small strip of film and we could get an image from it. But to get the resolution needed to really view the images, if we were to scan the whole film, we'd have to build a scanner specifically to image a reel of film. It would be challenging, to say the least, and take a couple of years, by which time the film was going to be soup, as it was described as. It was just going to turn back to a vinegary slurry, which was going to be awful. So when someone says, do what you need to do, that gets engineers and physicists like me excited. So those of a nervous disposition might like to look away now. We took the film to a laser cutter and cut it into 1-inch cubes because we can image a 1-inch cube. I would never do this normally. We were given explicit permission to do this. It was the only way to save this item. When you scan a 1-inch cube and you start paging through the various slices that you can produce from it, if you're of a certain age and you grew up in the UK, Eric Morecambe and Ernie Wise, whether you like them or not, you will recognise them. And we were just scrolling through this film, expecting to see nothing, and two very familiar faces popped out. It was a sort of a very high moment. It was surprising to see it work as well as it did. So we cut lots more cubes, worked with the BBC to scan these. So we scanned them, they played with the data, and you can see some of these are actually amazingly clear, given the state the film was in, and the fact we cut it into cubes to get about 3 frames per cube. There's some really, really clear images in there. And we actually managed to produce a fairly flickery video. This has now been released on DVD. I'm not going to plug it here, but you can find it online. And we ended up not going for trying to do full motion video. We ended up doing almost like a frame every couple of seconds just to get rid of the flickeriness. So if you are sensitive to motion, you might want to look away for a couple of seconds, but we actually got some with this.
Isn't it? I happen to be miming to Bing Crosby's voice, and beautifully as well. Not a word out of sync. No, I'm not miming now, it's me. You realise, of course, that the tape has stopped. Yeah, well, of course it started. It's started again. What are you doing? It's a thrill working with a small little genius. It's you talking now. I'm not talking like me, isn't it?
So that was, if that came through, hopefully it did. That was obviously from somebody, you know, that was a special collection, a very special item. There was absolutely no way that should have worked. So sometimes we just had to try things. But most of the work I have been doing has been on paper or parchment. That was just something I had to show, given I still had a couple of minutes left to speak. I will see if I can.
Well, David, thank you so much for that.
I've managed to stop sharing, but I've shown what I needed to show. Thank you.
Oh, thank you. And I think Jill has commented saying this is so cool and terrifying, but very cool. And I think that sums it up quite well. Definitely seeing that laser cutter eat into the film is slightly terrifying, but the results are incredible. I mean, Morecambe and Wise have never looked so good. So yeah, really impressive.
What you can't see from the image of the laser cutter is about 4 or 5 people standing around with fire extinguishers and ready to hit the red button, and everyone just completely nervous. But we had explicit permission to do it. We would never do that with anything else that we didn't have explicit permission to do it with.
It is incredible, and similarly with the sort of rolls and parchment and the letters as well. It's like you say, it's incredible what you can restore from an item that looks like it's otherwise had it, will never be salvaged, or you'll never be able to read it. I have been reminded that we do have to keep to time. So would it be possible if anyone attending today who has any questions could contact you directly at your email address?
Yeah, absolutely. My email address, I'll put it in the chat, but my details are all available. But I'm quite happy for this. If this is recorded to be shared, it's fine.
Fantastic. Yes, this will be shared, and any links or anything that you want to share as well, the conference coordinators will be able to circulate later. But so thank you again, David, for a really fascinating paper.
Bye.
And so, keeping to time, on to our final speaker for today. It is John Barrett, Senior Photographer for the Bodleian Libraries. Since 2005, John has provided photographs of Bodleian materials for numerous publications and projects. The subject of his talk today focuses on the use of cutting-edge 3D recording technology now being piloted at the Bodleian to reveal near-invisible text and artwork within their collections. Over to you, John.
Thank you very much, Alex. Can you hear me and can you see my screen?
Yep, we can hear you. We can see the screen.
Perfect. Thank you so much. Good afternoon, everyone. I'll be talking to you this afternoon about an exciting project which began at the end of January last year. It's called ARCHiOx, which is analysis and recording of cultural heritage in Oxford. And it's a collaboration between the Bodleian Libraries and the Factum Foundation, which I'll talk to you about shortly. The project was made possible through the generous funding support of the Helen Hamlin Trust. And in essence, the aim of the project has been to record originals from the Bodleian's collections in 3D using prototype recording technology. But why record library material in 3D? Firstly, to make discoveries, we can take an item which is difficult or perhaps impossible to record using conventional photography and create an image which shows only its 3-dimensional surface with its color and tone completely removed. This is an image of a copper printing plate, possibly from the early 18th century. And over 300 years, it's become heavily corroded, and the design has become difficult to see. If we remove the tone and the color and instead look at a render of the 3D surface of the plate, the engraving is revealed. What's even more exciting is to turn this printing plate over and record the back. Copper plates were valuable and often reused, and we know very little about the front of this particular plate, let alone the reverse. From the color image, we can see some horizontal lines, but not a lot more. But from the 3D recording, we can begin to see markings which were difficult or perhaps impossible to see from the conventional recording, musical notes and words. add some of the original color back in, and enhance and mirror the printing plate to make it easier to read, we're now able to see enough details that we can annotate over the markings, which can then be tidied up. And finally, with the image removed, we can now see the full design, a piece of music which was likely to have been inspired by Psalm 9, which is a brand new discovery made through 3D recording. But the data which is being captured isn't just used to make 3D renders, which are 2D images which show the surface of the original. The recordings are truly three-dimensional, and this brings us to the second purpose of making 3D recordings, the possibility to create 3D facsimiles. This is another copper printing plate featuring antiquarian Anthony Wood. Again, it's difficult to see. And here's the render of the surface of the same plate with the design revealed. But by loading a single grayscale image, which stores the changes in height of the surface of the plate into software, it's possible to see the recording in a different way. Now we can move over the surface of the recording, we can zoom in and explore every engraved line. With this recording, it's possible to create a facsimile. This is a 3D printer in the Factum Arte studios in Madrid, laying down incredibly fine layers of resin and slowly building a replica printing plate. Making a facsimile printing plate, it's possible to use it to produce facsimile prints. Here is the inked facsimile plate. And here's Adam Lowe, founder of the Factum Foundation, pulling it through a replica Goya printing press. And this is the resulting print, made from a copy of a printing plate, which was engraved 314 years ago. These recordings and the others which I'll share with you today were made using a new recording system designed and built by Jorge Cano from the Factum Foundation. Based in Madrid, the Factum Foundation are specialists in 3D recording and have worked extensively in museums, galleries, and important heritage sites throughout the world. Here we can see their recent recordings of the Raffaella cartoons being made at the Victoria and Albert Museum. And here in Egypt, where the Factum Foundation have been making recordings of the reliefs in the tombs of the Valley of the Kings since 2009. This is the recording system which they've used for the last decade. It's called the Losito, and it records the surface of originals using a projected laser line and 2 small cameras. But their new recording system and workflow, which has been used for the first time at the Bodleian Library, has many advantages. This system works in an entirely different way, recording 3D data through capturing 2D images, and then storing that 3D data within 2D images. Named the Selene, it can record originals at over 1 million pixels per square inch and height variation equivalent to less than 1/4 of the width of a human hair. So how does it work? With the camera in a fixed position, the original is photographed 4 times, lit from different directions, top, right, bottom, and left. The images are then analyzed in software in order to determine the surface of the original. These 4 source images, we can make 3 useful derivatives. Firstly, an image which encodes the direction of the surface at each pixel, using a combination of red, green, and blue to define the angle. This we call the normal map. From this image, we can generate a depth map which shows the height of the original at each pixel, using a lighter tone for a higher area and a darker tone for a lower area. In other words, we can store the 3D data as a simple 2D grayscale image. By loading the depth map into another application, we can introduce a virtual light source, which we can position at any angle or height to create a shaded render, which shows only the surface of the original without the tone or the color. As the 4 source images are simply 2D color images, these can be combined to make an evenly lit color image of the original 2. And this we call the albedo. This is a big advantage. Previously, using the Losito scanner, it would have been necessary to capture 3D and color data separately and align the 2. This slide shows a commonplace model for storing 3D data, a mesh over which a colored texture is applied. This is a depth map recorded from the same original. It's a far more efficient way of storing 3D data, perhaps 20 times as efficient. And it's because we're storing the 3D data in this way that we're able to record at extremely high resolution. So not only are the recordings more efficient, they are also 4 times the resolution achieved previously by the Factum Foundation. So let's take a look at a few more recordings from the Bodleian's collections. This engraved brass plate may simply have been made as a decorative object rather than a printing plate, as the engraved lines are incredibly shallow and faint. Despite this, the plate has clearly been used to make prints, and it's perhaps because of this that the central design has become very difficult to see. This is the 3D recording showing the surface of the plate, which has revealed the design very effectively. And for small originals, these 3D recordings take just seconds to make. The image of the render in this example has not been enhanced in Photoshop. This is simply a recording of the original surface. It's not just printing plates that have been recorded for ARCHiOx. Recordings of the prints themselves also reveal details which are almost impossible to see. This Japanese ukiyo-e print was made using wood blocks to apply color. Here you can see the impression as the paper is pushed down into the wood block from above. And if we zoom in, it's also possible to see these textural elements, which were skillfully applied as part of the printing process. Perhaps these can only be fully appreciated through this kind of recording, as they are extremely difficult to see when studying the original and would be impossible to record with conventional photography. This beautiful painted page belongs to a 17th century album made in the Mughal Empire. The recording made with the CILIP not only shows the individual layers of paint which have been applied to the paper, but also hundreds of pricked holes which can't be seen in the color image. The Sinhalese text from this palm leaf manuscript has been incised using an iron stylus or reed pen before being inked. This is the color recording, a render of the 3D recording, and a composite image which combines the two. If we zoom in, we can see not only the incised text, but also the careful pricking around the edge of this deer, which suggests that this design would have been transferred to make copies. This process of copying using pinholes can also be seen on the largest original which has so far been captured for the project. Dating to the 14th century, the Gough map is one of the earliest maps to show Great Britain in a geographically recognizable form. This is the render of the 3D surface of the map, captured at 700,000 pixels per square inch. And in order to capture the map at this resolution, it was necessary to record it as 85 image tiles, which were then stitched together. This is the highest resolution recording of the map to date, allowing researchers to zoom into specific areas of interest. When we look at the render of the surface, we can see groupings of tiny pinholes. These holes are evidence that the position of geographical features were transferred to the Gough map from an earlier map or precursor map. Studying the holes allows researchers to understand what this precursor map may have looked like and may help to date the map more accurately. Without the recordings made firstly with the Losito in 2015, And last year, with the higher resolution CILIP, this research would be extremely difficult or even impossible. The new 3D recording has been used to produce a double-sided, one-to-one, three-dimensional facsimile of the original. So from a medieval map to a medieval manuscript, the illustration at the top of this folio is incomplete. You can clearly see that the pigment which remains forms the partial outline of a horse. 3D render allows us to see far more of the design. Again, pinholes around the outline, but also these incisions which have been made using a sharp tool. If we combine these with the markings from the color image, we can start to see the design more clearly. By joining the dots, we can now see the front of the horse, and we can also see that the incised markings form a harness. This is connected to two horizontal lines, which, along with the remains of two inked wheels, suggest that the design may have included a cart or chariot. Given that the horse has too many legs, and that there is evidence of additional pinholes to the right of the horse's head, perhaps the original design may have featured two horses side by side. This annotation, which I've just shown you, comes from the first folio of this manuscript, dating to the 9th century. It's a homily written in Latin with glosses in Old High German, and the catalogue describes another annotation in the lower margin of this recto. Hunting scene, barely visible, but clear enough to make a digital annotation. The design was not made in ink, but in the same way as the harness from the previous example. A sharp tool, most likely a dry point stylus, was used to scratch the surface of the parchment. And these incised lines are incredibly difficult to see, and in most cases impossible to photograph conventionally. 3D recording made with the CILIP reveals far more of the original annotation. Not just the hunting scene, but also 4 camouflaged letters, RODA, recorded for the first time. But all of the annotations together, from the color image, the illustration from the 3D render, and the newly discovered text, we now have a complete recording of the annotation, perhaps 1200 years after it was made. Other illustrations made using a sharp tool have been found on at least 25 folios from this volume. A dog in this lower margin. Another one here below what appears to be a moon in the right margin. A capital D, similar in style to the one from the hunting scene annotation. And likewise, in this annotation, the capital A seems similar in style to the hunting scene annotation. So it could be suggested that these were made by the same individual, perhaps at approximately the same time. Where annotations are difficult to see from a simple shaded render, it's possible to use other kinds of shaders, adjust the position of the virtual light source, and navigate over the surface of the recording in 3D. For each annotation, this has allowed me to be as honest and accurate when drawing over them. The impressions recorded from the surface of the next manuscript may not be quite as striking as those from the previous volume, but this volume may allow us to answer some commonly asked questions. Firstly, is it possible to determine when the incised markings were made? In cases where the markings form words or illustrations, language and style may hold the key for researchers, but technology may also play a part. Though the initial thought might be that the markings could be made at any point in since the manuscript was produced, in some cases it could be suggested that they were made even before the manuscript was written. This small region of the lower margin is a good example of how the 3D recording reveals what is almost completely invisible from the color image. Interlaced pattern very clear on the left and with evidence of a similar design on the right. Here, the annotation has been added at the exact position on the color image. It's clear that these markings are linked to designs used in several decorated initials throughout the volume. This example from Folio 5 Verso. This one is from 38 Recto. Is the annotation simply inspired by the decorative elements from the initials? If so, it could be argued that it could have been made at any time. Or is there a direct connection between the annotation and the initial, which suggested that they were created at the same time? It's hard to be sure, but if we superimpose the annotation onto the image of the initial at exactly the same scale, we find that they're very similar in size and form. And so it could be suggested that the impression may have been made by the artist during the stint when the initials were decorated. This upper margin has a far more obvious annotation. The shaded render makes it even clearer. If we look at a greatly magnified oblique view, we can see that the lower line of the addition has been made through two of the letters. Not only has the incised line erased some of the ink as the incision was made, we can also see that the sharp tool used has transferred particles of dried ink to the right. From this, we can determine the direction of the incision, and we also know that it must have been made after the text was written. Markings in the upper margin of this folio tell a different story. These lines are fairly clear, but even more prominent in the 3D render. Here, the digital annotations mark the exact position of the markings. With the annotations removed, we can see that in this example, the lines have not erased the text. In fact, there's no evidence whatsoever that the text has been scratched. It could therefore be suggested that these markings may have been made before the text was added, perhaps during the preparation of the parchment. Up to this point, it's been suggested that the most likely tool to have been used to make the scratch markings would have been a dry point stylus, something like this. This would have been very sharp and capable of forming highly detailed text or illustrations. In some cases, these additions are tiny, perhaps just a few millimeters. Given that the lines from the second example may have been made before the manuscript was written, the tool used in this case may have been different. Perhaps the sort of tool that was used to rule the page. This wouldn't have been so sharp, broader and more rounded in profile. Taking measurements from the 3D recordings may help us to validate this theory. Here I've drawn a line through an incision and a profile has been generated. Both the width and the depth can be examined through this cross-section. This gives us very precise measurements of the tip of the tool used to make the incision. Here, the sharp tool has created a narrow and deep V-shaped profile. While the cross-section from the other example shows a much wider U-shaped profile. This is another example of a sharp incision into a lower margin. It's another case of the shaded render showing markings which are invisible from the conventional color recording. The digital annotations show two circular markings. In both cases, the focus of each circle is clearly visible in the render as a relatively deep indentation. This folio has a far more obvious example. And here the circle scratched by the divider is almost complete. So it's possible that the scratch markings in this manuscript may not have been made with a dry point stylus, instead a divider. And in truth, many different tools may have been used to make the markings. Examining profiles through these depressions may be useful for grouping the annotations. This may provide clues as to which may have been made during the same episode, perhaps by the same individual. Here is a V-shaped profile made with a divider or dry point, and a group of annotations made using a similar tool. Measuring the width of the lines is perhaps the best way to separate the annotations. The depth of the lines can also be measured, but there seems to be less consistency between examples. This is due to the minute differences in the pressure applied to the tool into the parchment. This is the U-shaped profile made perhaps with a tool used for ruling. Annotations with the U-shaped profile are much wider. The depth of the impressions are generally deeper too, up to 50 microns. So with these new photometric stereo recordings, we can see that it's now possible to conduct detailed analysis into the tools used to make uninked annotations. But do the annotations relate to the text? The dry point annotations recorded from this folio, from the homily that we looked at earlier, are not consistent with the majority of the others from the manuscripts. Here they have been added between passages of text rather than confined to the margins. Far less obvious and perhaps only recognizable from the 3D render is a small marginal illustration showing two hands tied together with a bow. Something like this. In order to determine whether or how this annotation might relate to the text, this image was shared with Jo Story, Professor of Early Medieval History at Leicester University. Her interpretation reveals a clear link between the annotation and the text. The text from this section of the homily describes the stoning of Stephen. The connection between inscription and text is most evident from this passage, the translation from which reads, "For many are called, but few are chosen." A passage from chapter 22 of the Gospel of Matthew. This passage immediately follows verse 13, which includes the text, "Bind him hand and foot." So a clear connection between annotation and text. And there are other hands to be found in the margins of this volume. As well as text and strange non-figurative illustrations. So who might have made these uninked annotations? This 8th century manuscript is a copy of the Acts of the Apostles, and it's been a focus of Leicester University PhD candidate Jessica Hodgkinson's research. Her research to my work, curator of medieval manuscripts Matthew Holford requested that I record the lower margin of this page. And here is the 3D render, an inscription made using a sharp tool, totally absent from the color recording. And believe me when I say it's impossible to see under conventional lighting. The inscription was enhanced using software and the digital annotation added. So what does it say? What is clear and complete is the name Eadberg preceded by a cross. The text which follows is harder to decipher. This is not the only inscription from this manuscript. Subsequent recordings have revealed the same name, either abbreviated or in full, 15 times. We can even see the name scratched into the initial on the first page. What perhaps makes these annotations particularly unusual and important is that they demonstrate an interaction with a female reader and an early manuscript. But as well as text, there are also many examples of illustrations, mysterious figures. Though they may appear very basic, we should remember that they are incredibly small, and it would not have been possible for the artist to clearly see the marks that they were making. It's been suggested that these figures may have been made by drawing round a finger or thumb. The render here shows another example very clearly. The Edberg discovery and the figures recorded in this manuscript have received a surprising amount of attention in the press. Perhaps this is because despite the annotations being made potentially 1300 years ago, we're all able to relate to making these kinds of informal pictures ourselves today. We've mostly focused on recordings made from Western manuscripts, but hundreds of originals from a broad range of the Bodleian's collections have also been captured with the CILIP. Like this painted page from a Persian manuscript. And this 2,500-year-old clay seal sent from a Persian prince to the steward of his estates in Egypt. This impression and 6 others from the collection were used to recreate the lost cylindrical seal which would have been used to make them. Conservators and curators have also explored how 3D renders may assist with condition reporting. Photometric stereo recordings are extremely effective in recording flaking pigment, historic repairs, and insect damage. What has been proven through the recordings made with the CILIP is that photometric stereo imaging is every bit as effective at unlocking the mysteries of collections material as established heritage science imaging techniques. Given the range of possibilities which the CILIP recordings permit, measurement, virtual relighting, on-screen 3D navigation, and future-proof data suitable for the production of 3D facsimiles, photometric stereo is without doubt a significant new addition to existing methods of cultural heritage imaging. If you'd like to find out more about ARCHiOx, you'll find several articles on the Bodleian blog, The Conveyor, explaining more about the technology and the recordings I've made. Very much.
Thank you, John, for that fascinating insight into a truly remarkable piece of technology. It's just incredible the amount of detail you're able to see when you have those images without tone, and to sort of cast light in various ways, as you've shown. Really, really incredible. And as you've illustrated, some incredible applications as well, beyond just observation, but also, let's say, conservation as well. We have a few questions, and I'd invite everyone else to submit your questions in the Q&A function if you can. But one question is, an individual is curious to learn how librarians came across specifically the markings of the animals, but I think actually applies to some of the later examples you showed as well in the manuscripts, considering that they're almost invisible to the naked eye. And then this person goes on to ask, were the markings the reason for the rendering being taken, or were they discovered completely by accident? So I suppose that's a question more about the workflow between you and researchers and curators.
Absolutely. So the Edberg annotation that we looked at together was discovered by a PhD candidate, Jessica Hodgkinson. She saw a very clear marking, which had basically been sliced into the page on one of the folios from the same manuscript, and had the good idea, after receiving permission from our curator, to look with a torch at a very low angle at each folio, and found what appeared to be some markings, but she certainly couldn't work out what the text was. And actually, when I looked at the page in question, I thought there was no hope of making a recording. But what the CILIP revealed was absolutely stunning. And I remember calling her a few days later after recording several pages and saying, look, I found 15 more. It's absolutely amazing. So yeah, really wonderful. But I think it's such an important aspect of the project to be working with curatorial staff, with professors, with PhD students, and taking their suggestions, giving it a try, because I think the project's grown sort of organically through doing that.
Yeah, of course. And I mean, looking ahead, what do you envisage sort of future applications for this being as well, beyond what you've already explored? Is there anything sort of immediately on the horizon that you think, or any projects that you're currently working towards that could see a different new application for this kind of technology?
I think the goal in the second year of ARCHiOx, which is just about to start, is to take this technology and record collections material across Oxford University's collection. So not just the Bodleian, but also the Ashmolean and the History of Science Museum and the Natural History Museum, to see what we can do with photometric stereo for their collections. Something that we've been doing recently is recording some of our original artworks, so paintings, excuse me, and drawings, and having a look at preparatory markings, things like that, because it's really producing amazing results.
And we have a question here from David, who asks, have you looked specifically at inscriptions on wood? I guess what have been your observations working with wood, if you have?
We have. I've recorded some wood blocks. The problem is that this substrate has to be fairly smooth, otherwise the surface of the substrate sort of overtakes the intentional markings. There is a way of filtering for different textural frequencies so that you can dismiss some of the sort of natural roughness in the substrate. But it's something that I'd like to do more of, certainly. We've been doing recordings of wax charter seals, for instance, recently, and also experimenting with photogrammetry as well to record some of our textile bindings and things like that. So there's an awful lot going on.
Excellent. Well, thank you very much for sharing that with us today, John. Thank you for your talk. I can see that I think David's quite keen to follow up with you by email as well. So I'm glad that we're able to make these connections with people at the conference. I suppose that's what the conference is all about. But yeah, thank you, John, and thank you as well to all of our other speakers from today, David Mills, Raffaella, Losito, Maciej Pawlikowski, and to our keynote speaker, Mia Ridge. I've been asked to address just one or two housekeeping items before we finish. So unfortunately, our first speaker for tomorrow has had to drop out at the last minute. So that means that we'll be beginning tomorrow at 2:30 as opposed to 2 o'clock British summer time. So that's 2:30 start tomorrow afternoon. And you'll be able to access the webinar using the Tuesday link, which has been provided to you in the program. If you have any issues with accessing the session at all tomorrow, please do contact one of the conference coordinators. Their email addresses will have been circulated as well. So that's all from me. Thank you again to all of our speakers, and I hope many of you will be able to join us for the remainder of the conference over the next 2 days. Thank you very much. Goodbye.